A warm welcome to Father Jace with Thomas, Financial Administrator, Jayanti College, whose leadership empowers us all. We also extend a hearty welcome to Dr. Vijay Kumar R, our esteemed head of the Department Commerce, and all the faculty members of the Commerce Department whose support has been invaluable. A special welcome to all our participants from various institutions across the nation. Your presence enhances our learning environment and encourages collaboration. As we begin today's session on constructing and testing structural models in Amos, I urge everyone to actively engage and make the most of us, Dr. Saxena's expertise. So I'll hand over the session to our resource person.
Uh, Thank you so much, sir. Thank you so much for the introduction and the pitching the session for the day. So, what we were doing, yesterday, a quick recap of what we have done by now. Let me just share the screen. So today we'll be talking about some very interesting things, and we are on the day 3. So, just a minute. Yeah. So today we'll be discussing about some very interesting things about the analysis, and I'll be sharing some key resources. I've shared some material with the coordinator of the FDP. They'll be sharing in your group as well. So we'll move on with that thing, and just to basically quickly recap what we have been doing in last 2 days. So we have built an understanding of the basics of Amos by now. So we have understood where we can actually use the Amos, what are the basic utilities where we can apply the Amos. So we have a bit of a discussion. We had math analysis. How do we see the coefficients and other things? I'll be, gazing those things today and tomorrow again. So yesterday, we started with something like confirmatory factor analysis. So today, we just, drew the diagram. So today I'll be telling you some better ways of drawing the diagram, formatting it in a better way, because yesterday in last 2-3 minutes, we had very limited, resources in terms of time. So I just randomly, drew a diagram. So today we'll be doing it more systematically and see. We'll try to cover the mediation and moderation part today itself. Otherwise, we have tomorrow's day to cover that. But I want to introduce you to the world of plugins which we have in Amos. So we have one beautiful set of plugins which are very, very handy in terms of making your analysis work very easy. When you're especially working on a software which is not much known to you, so you can use those plugins to get the desired output in an easier way. So that is what we are going to learn today. So today we'll be probably moving to this. After CFA, we'll move to this mediation and moderation part. I've covered this theory part under day 1, and few things, just what we have covered already, that we have something called latent variable which is not observed. We have some observed variable which were in the rectangles, so we were drawing them. And we have also discussed about the measurement model and a structural model. So what I told you today, we are talking basically on this day 3, we are moving to the structural models. So this structural model is basically the set of unobserved variable which defines the relationship that you want to study, more prominently used in the path analysis. And the measurement model, is something where you measure. We have 3 measurement models in this bottom diagram here. So this way you can see, okay, this is one measurement model which is measuring one factor, the second measurement model, and then the third measurement model. So we can club them together, and that's what we normally do. So yesterday, we had a discussion on the standardized and unstandardized weights. So I was using some other laptop, so I could not show you this particular PPT. So just to brief you again on that part, then we'll move to the Amos, working. So unstandardized weights are normally the raw coefficients, mostly like variance and covariance, and they are in the original units of measurement. So this I explained in the yesterday session too. So these are, very, they are not adjusting for any deviation or scaling issue. When you have 3 different variables, they might be coming from 3 different scales. So Then in unstandardized standardized weights, we don't adjust them for that scaling gap. So these are the unstandardized estimates. Normally, variance, covariance, they're taken as unstandardized weights. But when you talk of standardized weights, they are actually adjusted to have the same scale. Let me give you one basic example. Correlation, for example, adjust to one particular scale, that correlation value of two or more variables will be always then, less than in the range of -1 to 1. So this is a universal thing. So that is a kind of a standardized kind of a standardization that we do in the correlation. So we may be interested in adjusting estimates to that thing if we are having three variables, four variables, or more than that number, and we are having something like on the different scales. So that is something that we do in the standardized estimates. In general, most of the softwares like SPSS, Excel, or other things, when we run a regression, we get the unstandardized estimates, which are used for building the regression models too. So this is something that which we can understand. So both of the estimates have their advantages. Unstandardized estimates are useful for interpreting the model in terms of the actual data values, while the standardized estimates are helpful for understanding the relative strength of the relationship between the variables. So they have different utility altogether. Exogenous and endogenous variable we have already discussed on day one, but just to remind you once again, the endogenous variable is a dependent variable. So I remember it with the D coming in that word. So endogenous variable is something that is dependent in nature, and the independent variables are also cited as exogenous variables here. So this is what we have done, and today what we will be doing, I've shared one particular image also, and this PPT will also I'll share, by the end of today's session, after the end of today's session. So you will be able to assess all those things. So in general, what happens when you'll be testing the model fitness? You have done the confirmatory factor analysis. You want to know whether your model is fitting or not. This particular analysis gives you proper results or not. So there are various measures, various matrices, various indices that allows you to check. So the most prominent one I am just quoting here. So what you can see that, okay, you have x square, that is chi-square, sorry, chi-square, and that is this value should be the p value of this test should be more than 0.05. We have GFI, AGFI. Normally, any value above 0.9 is okay. 0.95 will be great. NFI, TLI, these are normed fit index and Tucker-Lewis index. So they are also, if above 0.95, they are excellent. Above 0.9, they are acceptable. We have comparative fit index, CFI, which value again should be equal to or more than 0.90. So what I normally, for the beginners, I normally tell them that any word, that is GFI, goodness of fit index, NFI, normed fit index, Tucker-Lewis index, that is TLI, comparative fit index, that is CFI. So anyway, when you see that I word, being next to that, measure, the any value above 0.9 is or equal to 0.9, is acceptable here. There are three, values that you should be, very careful. That chi-square value here, we want p value should be more than 0.05. We want our null hypothesis to be accepted here. That model fits perfectly. So we want this, hypothesis to be accepted. And then RMCEA, that is root mean square error of approximation. This value ideally should be less than 0.08. Less than 0.10 is acceptable in some cases. So there are citations for those deviations. So these are like, nothing is like a threshold here. We have citations for everything, but yeah, in general, understand, okay, the indices values that we are talking about in this, GFI, NFI, TLI, CFI, they all should be, above 0.9. The higher, the better. The maximum value can be 1. Chi-square value, ideally should be more than 0.05. So then it will be, your model fit will be considered to be good. RMCE, that is root mean square error of approximation, should be less than 0.08. RMR value, should be, again, the root mean square residual value should be less than 0.08. So the description is also given here, and you can explore further those kind of things. What I've done today, I've shared 2 ebooks, with the faculty coordinator of this FDP. So what you can, do There's a Cooper and Schindler book of research methodology. You can refer to that book, and for the basic understanding of the research concept, it is a very, very good book, I say. And then I've also referred to one book that is here, multivariate data analysis. So higher book is there, so you can refer it for that practical hands-on kind of thing. So when you want to do something there. So these two books, something that I normally advise any researcher, they should be taken that. Uh, Dr. Nirupa Chauhan is asking me one question, that if the values are between zero point 0.8 or zero point 0.9, will it be considered? If you go by the threshold, and I'll be telling you the plugins network, so they'll be putting it, they'll not be saying it excellent, they might call it good. So that is a point. Ideally, when you're reporting the findings for a research paper publication, 0.9 and above, is taken as the acceptable. So at least 0.9 or more than 0.9, will be something that will be acceptable in that regard. Otherwise, if you are citing something, which is away from the threshold or less than the threshold, you need to search for a citation. Someone in the statistics must have shared some kind of, validation for that acceptance. So that you need to cite that in that particular statistical analysis, in this particular setup, this kind of deviation has been accepted. So we are citing that particular thing. So that can be done. That's a way out. Right. For hypothesis testing, which inferences are considered? Please elaborate on that question further, then I'll be able to answer that. So as of now, this is the theory part that we have already covered, by now. So let us quickly move on to the Amos part here. So one more thing before moving to that Amos part, what I'll be doing today. I thought to discuss this on day 4, but let me just collaborate all those day 3 and day 4 learnings together. I've shared this link again with the coordinators, so once they'll be sharing to you. Otherwise, you can quickly search on this, Gaskination, or James Gaskin is the, resource person for that particular thing. So he has a dedicated page on the Wikipedia, and he's a wonderful professor, let me tell you, and he's a very, very renowned name in case of one question has popped up to me, that is, we need all the fit indices to be on the threshold to say that model is fit. If a perfect fit is there, then yes, all the indices will be supporting that logic. But in practical cases, what I felt like sometimes, out of 10, maybe 6 or 7 indices are fitting, and rest 2 are maybe like good, as someone asked me, 0.8 to 0.9. So they are okay. They're not great, but they are maybe okay. And one, is parameter is not fitting at all. So what you can see, then you need to understand broadly that which index is measuring what kind of model fitness parameter. So if 7 indices are fitting, 7 out of 10 are fitting, though majority of the indices are fitting. So majority of the fitness parameters are being met. So we can say in this our output or interpretation, that out of the 10 or whatever number of total indices you are measuring, 7 are fitting. So that gives you a fair understanding that model is fitting on various parameters. Where the model fitness is not being achieved, we need to sort of explore that further. What are the reasons? What are the measurement issues? So that is a point. Yeah, this is the link that Professor Dhanpal has shared in the chat box also. So you can refer to that particular link as well. So this is the James Gaskin. He's a professor at Brigham Young University, and he's a very renowned name in the field of structural equation modeling. He has a wonderful set of tutorials on Amos as well. So if you wish to learn further, please refer to this thing. Another gentleman whom videos are very nice, that is Mike Crowson, M-I-K-E Crowson, and C-R-O-W-S-O-N. So his videos are also very good. So you can refer to their resources further if you wish to excel further in that domain. Now, what I want to explain you in this particular thing, there are a few things that I will explain you. Like they have given you certain topics on the left. So if we are talking about confirmatory factor analysis today, so I'll just click on the confirmatory factor analysis, and when you see here, so they are also measuring this, measures and threshold. So they are also saying that. So when I said that 0.95 above is great, 0.90 is traditionally okay, and 0.80, sometime, CFI may be permissible. So you have to find that particular, citation for that thing. So these things are there. So normally this book I was referring, this here et al. 2010, they have, I guess, one more edition after that. So you can refer to this book. This is a wonderful, wonderful read. I'll advise you to read it thoroughly, to build the understanding. And don't worry that the language is very simple. Even a layman and the beginner can attempt to read it. So there's nothing like it. So you can try and read it, and it will develop your understanding of the concepts very well. Now, one thing is important. We'll talk about the modification indices here. So there are certain, things which are acceptable. There are certain things which are not acceptable. Let me just make you understand this. Let's say my model fitness indices are not coming to be great. I have to improve the fitness part here. So how can I do that? So I'll be telling you how to work on the modification indices today. So once I see that okay, there's some covariance issues in the error terms. So covariance, of the error terms, can be sorted with this, kind of covariance addition among the error terms of that particular, factor. But one important thing that we need to understand, that you can covary the error term of a single factor, variable. It is very important to remember. So as you can see on the left hand side, what we see acceptable, that error terms can be, covaried, but they should hail from the same factor. We cannot do like this, as we are seeing on the right hand side, that someone is covering the error term of one factor to the other factor. That is not acceptable. So this is one thumb rule that we need to remember. Another thing is we cannot covary, the error term with a latent variable. So it is not possible. We cannot even, uh, design this, what is the logic of covary between the error terms? Sometimes, what happens, the covariance of the error terms put together is very high, and we are not modeling it in our model. So what do you want to, say by covarying the, error terms here, that we know that the covariance is very, very significantly higher. So let me put it in my model also. So that is like you are addressing that relationship that exists in your model and which you are not normally doing. So that is the basic logic of putting this covariance, between the other terms. This question was asked by one of the participants. So we cannot, what you are understanding here. So when we'll be working on the modification indices today, we'll see all this part here. So we can, put the covariance term between the other terms. It is allowed, but the only condition is the other term should refer to the one single factor. And other way around, any kind of innovation or modification is not permissible. We cannot put the covariance term in the error terms, from different factors. We cannot have any relation between the observed variable of one factor to the other factor. We cannot do that, and we cannot put a covariance term on other term of one factor with the other factor. That is not allowed. So we cannot do that. So these are the basic thumb rules that you must remember. So we'll discuss about all those things, and we'll talk about the validity and reliability. I told you today we'll cover that topic as well. So my idea is that by tomorrow I'll be completing mediation, moderation, and CFA validity, everything like that. So that's why I thought, let me introduce you to the world of plugins today only. Otherwise it will be too late. So there are like construct reliability will be measuring that should be more than 0.7. Convergent validity and discriminant validity, I'll explain that concept later, but the thumb rules are that AB is should be more than 0.5. So this, this basic information is available on this page, and they have given you proper, references also. So if you wish to learn it further, you can refer to that particular, reference material for further, elaboration on those things. So it's wonderfully placed things. So one thing is that you can refer it for the short theoretical references here. The important thing that I want to introduce you to is the plugins folder. So on the left, you see the plugins folder here. Please click here. And the moment you click here, you will be directed to a drive link. So you will be, he has a drive link that is placed, for all the plugins here. One thing that you must check before doing that, which plugins, you you are referring to. Your version of the Amos, should be seen first. So I'm using Amos 23 right now on this particular system, which I'm demonstrating you today. So on this laptop, I have Amos 23. So I should be very careful that my plugins which I want to refer are going to be in this folder. So if you're using 24 or 25, you can refer to this folder. And if you have higher versions, you can refer to the concerned folder accordingly. He has certain other plugins also, which is not his, developed. So he has also shown that particular folder in a different folder. What we need to do, let me just show you which versions I'm using. So I'll just quickly show you that. So I'll just click here and version 21 to 23. So these are the basic plugins which are available. Now, the beauty of these plugins is that, for example, I'll be using this plugin today. Yesterday, you saw in the last 5 minutes, when I was drawing a diagram, I quickly, tried to draw a diagram. I was dragging it, all the things, but it took me some time. So when you have a data set in SPSS and you have the, some kind of, let's say, basic output of some kind of covariance matrix or something like that, you can use that matrix data to make a diagram automatically. So I hope you remember the pain of drawing a diagram, not getting it in the perfect shape that we were doing yesterday. So this plugin, help you to draw the diagram at single click. I'll show you how we do that. If I want to check the model fitness, I'm a very novice researcher in this domain. I don't know how to check the model fitness. So this will help me to see the basic model fitness, and it will give me the interpretation also, along with the output table. So I'll show you how does it work. Another thing is master validity. So if you want to check the construct validity, you want to check the, uh, convergent validity, if you wish to check the discriminant validity. So all that, analysis is also done with the help of this plugin. These options are not available in the Amos by default. That's why the plugins are required. Plugins are the added on feature that we want to install in other system. And it is also very, very useful, if you want to sometime, what happened, I just created a model yesterday and I knew I wanted to erase everything that I've drawn. So what happens, you have to select all and then erase using that thing. So you can actually erase all at single click here using this particular plugin. This is a very simple thing. Erase select, you will select few things and you can click on this. Magic Clean is also one very useful plugin. So that is the plugins thing. So once you will be doing what? You will be downloading all the plugins from here respondingly. Please check which version of the Amos you are using. So if you are using 21 to 23 version, this folder is meant for you. If you are using higher version, please refer to that particular, versions. In the higher versions, let me show you what they have added. In the 24 and above thing, they have also added the 24 version. That is, they have added HTMT, which is a measurement of, folder 29 has only one, Satish sir, you're right, because the 29th, Amos has come recently and they are in the process of developing the plugins that way. So this is the thing. Thank you, sir, for sharing the link again here. And do we need these plugins for 26 also? Yes, we need Abhaji. We need those plugins for 26 version also, because every version, will have common 5, 6 plugins that is by default provided by the Amos, like draw covariances terms, name unobserved variable. These plugins are by default provided by the Amos, but these are the added-on plugins which are developed by some technical people, and this can be added into that. So folder 29 will have only one. By the time coming up, will be they'll be adding on some plugins for that version. Yes, sir. Any version, will work. I'm not sure if you're using Amos version 24, you should be referring to the plugins of version 24. That is the one important learning here. So in 24, they added substantially, higher amount of version. I'll not be able to explain everything, but we have indirect effect plugin here. We can have HTMT plugin here, which is a very, very useful technique nowadays. And we have master validity, two type of things. We have model biases there. We have multi-group analysis here. So many things have been added in 24 version. So ideally, if you're using Amos 24 and above, so then you can refer to this folder and your work will be very, very easy. Now, Coming back to the thing, if you have installed, you will download these things from the Google Drive easily. We have the viewer access here, so we can download the things over there. So once we download, how to use them? What we need to do, this is the, I told you this is the plugin folder. So plugin folder was there. And one thing that you must remember here that in plugins, the installing plugins, let me just show you that. Yeah, plugins guide. You click on the plugins guide here. This is important thing because every version has a different way of using the plugins. So if you are, I'm right now on 23 version right now. So 23 or lower, what you have to do, the files that you will extract, I'll show you how they look. So let me show you this. This is the download folder. I probably added on some plugins today only. I deleted that file. So let me just show you that. Once you will I'll show you that process. I'll explain you for then, and then I'll show you the process. So once you download all the plugins, extract the file. You will extract all the plugins file over there. DLL file, V3 files will be there. Extract that folder, copy all the files, and then you have to paste it in this path. So you will open the C drive, then you will go to the program files, IBM folder, then SPSS, then Amos, and then 23. And there's a folder called plugins there. Just paste all the plugins from that extracted folder. If you're using 24 to 26 version, then you have to follow this path. So C drive again, then you go to users, whatever username, the admin account you're working on, use that account, go to app data. This app data, will be normally a hidden folder. So please make sure that you are opening that hidden folder view option. So then you'll be able to see app data because Windows doesn't want to change the app data on your own, but this is something that you are adding in on software, so you can do that. So you go to the app data, go to local folder, Amos development, and then Amos and Amos version, whatever you're using, and then plugins folder is also there. So you can paste those folders over there. So once you do that, now this is one very important thing. So if you're using Amos 27 or higher, so they are mentioned that they are fixing and updating plugins for version 27 plus. So they are working on it right now. So they are working on the plugins to be added in that version. So that's how it works. So I hope that process is okay to everyone. Let me just now go to the Amos software, and I'll demonstrate you the utility of this version here. So I have opened the Amos here. I'm sharing one. I'm not sure. I'm a very slow person on the WhatsApp, so I'm not seeing whether just to show you that file. Okay. So let me check whether ma'am has shared that file or not. I have shared one file of CFA2. So that is the file that we want to work on today. Yeah, it has been shared. So file has been shared. So I have shared a file called CFA-2. It was shared before the session by the BAM. So you can refer to that file, which I'll be working on today. So I'll just open that file first, and then I'll show you. And I'll be talking about intermediation moderation on all this data only on single file. So that you develop the fair understanding, how do you work on that data set. Yesterday we were the file that we were working on yesterday, was a very heavy file, and it was having certain variable names also. So we need to remove the variable labels from each version. So that was a difficult task. So I'll be using this simplistic file. I've developed this file, and you'll be able to run this file easily over there. So once you open the file, you will see that this is the kind of data we see here. There are 5 factors here. So this was again, I've taken this data from somewhere, but this data is having 5 different factors data. So we have 3 questions each per factor here. So there are 5 factors. I'm not naming them any HR or marketing or commerce related thing. They are, commonly, A1, A2, A3. That means we have factors, factor A, and there are three variables in that factor. We are asking three questions in factor A. We have B factor here, and then we have C factor, then we have D factor, then we have E factor, and for each factor, we are having three questions each. So how do we proceed here? I want to use, a plugin here. So I'll show you how to use that plugin. So before doing that, let us quickly go to the analyze. I'm on the SPSS right now. I'll go to analyze and go to dimension reduction here. That is the factor analysis. So click on the factor analysis, dimension reduction. And once you click on the factor analysis, you will select all the factors here. So all the factors, all the variables, you have in your data set, you'll just put them in the variable. We are running the EFA right now. Please understand. We are running the exploratory factor analysis. So now you click on few options here. Let me click on the rotation part first. I want to select Verimax. I'm not going to explain you further on the EFA. I'm just using some standard, benchmark things. I have to complete a most part, so I'll be skipping that explanation of this. So, but what steps we are following? So we are referring to the Verimax, rotation. Click here, and then there's one option, here that is we want to suppress these small coefficients. In the rotation matrix, what happens? You don't want to see every number. So if numbers are less than a particular value, you can remove those values. Otherwise, manually sometimes we do that. So we have an option in the SPSS itself. So let us use that option. I'm using 0.4. So any value less than 0.4 in the rotated matrix, will be removed by the system now. So I'm just using these two things. What I've done, I've just taken all the variables in the variables list. I've used rotation, Verimax, rotated solution I'm looking for, and the options. I've gone and suppressed small coefficients less than 4.4. So this is how I am going with and click OK here. So this will give me the factor analysis output. So there are 5 factors which are explaining 68% of the uh, no, Nandini, this 0.4 was not a standard measure. I just, just to reduce, I didn't know what will be the exact rotated component matrix value. So I just had something like less than 0.4. I will not be entertaining. So I've just removed less than 0.4. So 5 factors are there, and 5 factors all put together, have this 68%, total variance explained, which is okay. And you see this rotated component matrix we see here, and it looks very clean. So the first 3 factors are moving to first factor. The second 3 factors are moving to the second component factor. So they are well placed here. I knew that they're well placed. So this is the matrix that we are getting. So this is a perfect, factor analysis that you see. Okay, no factor is loading to the more than one factor. No variable is loading to the more than one factor. So it is a perfect thing. So if I would have done what you were asking, Nandini, if I would have done with 0.3, I worked on this data earlier, so I know. So if I would have worked on 0.3 and I click OK, so you'll see in this method, you'll see some values which are more than 0.3. So let's say this B3, they're having the loading of 0.3 and 0.7. Obviously, it will fall in the second component. So, but this I have to remove manually now. Again, this E2, it is more than 0.3, and this will be falling in component 3 and 4. So just not to do that, I went with this factor analysis where I had the score of 0.4, which gives me clean rotated component matrix. I use that way. So what is important? The important thing is that every variable should be linked to one particular factor. So that is what we are able to achieve. Now let us use some plugin part here, right? So let me just come to the Amos file here. So let me just I'll open a new file. This is a blank sheet here that we are using, and I'm not changing interface today. Let me add data file. First of all, I want to add data file here. So the data file I know is in which folder. I'll navigate to that folder. And then I'm working on CFA2 copy right now. So I'll just take that file, click OK. This file is linked now. You can check whether the file has come in the data. Yes, it has come. So you see that, okay, we have these variables in the data set. So we have, A1 to E3 variables in the data set. Now, earlier, what I was telling you yesterday, we were drawing the model on our own. So today, what we'll do, we'll use a plugin here, and plugin will help us to draw that model. So let us use the plugins. My plugins are already pasted in that folder, the desired folder. So I'll select this pattern matrix model builder. And this plugin is available for 23 also, 21 to 23, and this is obviously being retained in the higher versions. So I'll click here. So what I need to do, I'll just go back to my SPSS output here, and this is the rotated component matrix, which tells me which variable is loading to which factor. I'll just copy from here, and this link which I copy, I can come and come to my this pattern in a matrix input, and I'll paste it here. That's it. Do not change anything. Do not do any innovation here. Whatever you just copied, you just paste it here, and then you create diagram, and you see the magic. The diagram is ready. So you will see some input here. Okay, we need to see what is the problem. Error variable. Okay. So endogenous variable has a residual variable associated with it. So that's what the warning is there. So we'll continue with that. And this diagram is ready. So if we would have drawn this diagram, we would have taken some time for sure. We could have drawn it quickly though, but it would have been definitely, taking some time to us. So what we have achieved here, we have achieved one, set of, this is, I can change this name. If I wish to change this name, I can change this name. Let me just remove this further. Okay. So we are good to go. So we see that model is there. One thing that we were, facing a problem yesterday. So what I can do, if we wish to, expand this, A1 looks smaller to me. I want to have a larger space here. So what I could do, I will click on the preserve symmetries here, which I was saying I will be telling you tomorrow. Yes, tomorrow. So you just click on the preserve symmetries here, and then there's an option of resizing, shape of an object. So if you wish to change the shape of the object, you can actually play with this. So this will help you to do that thing, without affecting the symmetries of the thing. So you can actually do that. And even if you wish to, have the similar things, you can also use this option here, drag properties from object to object. So you can click on the drag properties of object to object. And if you wish to have similar height, similar weights, so you can just click here and close it here. And if you say that, okay, I want same thing here, I want to have same thing here. So you can just quickly, drag these information from that particular parameter. This is all possible here. So that we can do. I'm just expanding the things manually right now. So we have got this diagram ready. So if you wish to see whether you have got something in the variables, yes, we have got everything in the model as well. So we have got some error terms as well. So diagram making was quick and easy with the help of this plugin. Otherwise, we would have done it manually, which would have taken obviously some time. By default, as we discussed, error term will have that weight of 1 leading to the observed variable, and in every measurement model for each construct, we'll at least one error should have the weight assigned to the 1. So that is one thing that you should remember. System, when it develops the diagram on its own, takes care of that problem itself. Now we are done with it. So let me just go to the analysis properties. We want to check a few basic things. I know my data has no missing value, but still this check is there. If you wish to remove it, you can remove it. If we want standardized estimates, we want squared multiple correlation, that will be sufficient here. Let us click on the modification indices and residual moments. You can click on these two options as well. I'll tell you the relevance of these two options once we'll check the fitness part. So this is, I'm closing. I have not saved it yet, so I need to save it so that I can run the analysis. So I'll just quickly save it somewhere in my folder that I'm working on. So let us save it in this folder only. So this is, okay, I'm just going with that thing. And this is CFA day 3 that we are working. So that's how it goes. Yeah, Nandini, I just copied the rotated component matrix table from the SPSS and I just pasted it in the plugin of that pattern matrix, that was there. So I just used this pattern matrix model builder. So it allowed me to frame the entire diagram at one click. Otherwise, I would have done it manually. So creating the diagram, then dragging the individual variable to the boxes makes your task bit lengthier. This plugin helps you work in that way. So we are done with it now. Let us quickly run the. Yes, we'll cover that tomorrow, sir. Reflective and formative component we'll discuss tomorrow. I'm not complicating right now that thing. I'll discuss that thing tomorrow. So let us calculate the estimates now. Okay. There's more. Okay, we have E1, E2, here E1, E2, E3 because we have the variables named with that thing. And we also have other terms which are named E1 and E2 and E3. So let us change the name here. So other terms are going to the 15. Let me call it 16. Other term can have any name. This 16 after that will become 17 and this will be 18. So that is one change that we will need to do. So that is okay. Now again, try to run we have saved the file. Let us run the analysis. So we just quickly calculate the estimates. Okay, let me just check what is the problem here. Okay, we got a warning, but we got the results as well. We got the results, so we'll go move on with that thing. So these are the unstandardized estimates that we are getting here. We get the standardized estimates. We have discussed that part yesterday, that these are the standardized regression weights. These are the, if you go to the unstandardized thing, so there will be variance and covariance kind of things and unstandardized regression weights on this thing. There's one plugin here which helps you to understand, what you are getting. So if you're not very comfortable with understanding what you're getting, so you can click on the name parameters. So you can just click on the name parameters. Abha, I changed the error term name because this E1, E2, E3 was the error term name associated with a construct. But in this third set, you see there's a variable name also is E1, E2, E3. So we can't have E1 as an error term and also as a variable name. So that was a duplicacy that was spotted by the Amos. So that's why we need to change. So I prefer to change the error term name. So that E1, E2, E3, that's what we did that. Thank you so much. So if I want to check the parameters here, so I will just quickly click here and click OK. So what it does, it tells you what is being calculated. So if you run the analysis here, so this will tell you this V word will be there. So you will understand, okay, V stands for variance. So once you will see the output here, so you'll see, okay, what is this thing? So when you click on the path diagram, you will understand variance of error term. So this is variance here. So variance of the error term is on this side. So if you see what are these values, you can go back to the thing here on the input path diagram. It will tell you it is W1, W2. So weights, regression weights. And what are these arrows indicating? They are indicating covariances. So this is a point which helps you to understand, what we have done. We have used a plugin that is name parameters. So if you're not comfortable in understanding what we are getting in the output, you can use this thing easily. And standardized estimate, if you click here, so again, you go back to the thing. So this is these correlation values. These are the variances and these are the regression weights that we get in that thing. So let us now understand the fitness point. So I'll go to the output here. I'll just quickly got the output. And in output, we'll see the estimates. And we'll go to the estimates. So we'll see that basic covariances and other things over here. So these are the things, and then modification indices, we'll be discussing about that thing later. Let us quickly go to the model fitness here. So in model fitness, I've shown you a few things like chi-square value, the p-value should have been more than 0.05, which is not coming good here. The GFI, AGFI, are okay. They are above 0.9, which are acceptable. RFI is slightly on the lower side, but IFI and Tuckworth-Lewis index and CFI are good. So they are above or close to 0.95, which is what we want. So you won't be able to make interpretation for all the fitness indices like that. So whatever you are comfortable with, and the sheet that I've shared with you is the most commonly used fitness indices. And if you wish to expand your knowledge base to all these things, you have to sort of search that what does it mean? What is ratio, P ratio, and what is PNFI, what is PCPI? You need to sort of search for it and then understand what they are measuring and telling you. What is the beauty of plugin, which I told you? Let us go to and use the plugins here. So you can click on, let's say, the validity and reliability test. So the moment you click here, this will run the analysis, and this will take you to a browser page. So these are the model validity measures. So few things that importantly you can observe here, that in validity we have the construct reliability here score. If these scores are above 0.7, they are considered to be good. So you can see that the comment is there, at the bottom, you'll see the comments are there. So the reliability, for CR4 and CR5 is lesser. So they are also saying that the reliability for CR4 is less than 0.7. We can remove D3 to improve the construct reliability. So the problem area is identified here. Similarly, reliability for CR5 is less than 0.7. And here C2 is somehow creating some problem here. So that, this suggestion is also popping up to you. So you can obviously modify your data, somehow add more data or try dropping some variable, and that will help you to get better reliability scores for the problem areas, which are highlighted as red as well. First three constructs are having very decent values of construct reliability. Now, if we talk about the AVE numbers here, so AVE, convergent validity, the AV for factor number 2 is less than 0.5. So these are like marginally less than 0.5. So we can improve on these values by dropping some variable. If we have larger data set, so that will be helpful. We can try removing B3 to improve on the AVE part here. So that is how that recommendation also pops up. So that is one thing. And if you wish to see, the other things like that, so you have the convergent validity being established here. You can see the reliability being established here. So even if you further, you could just take the square root of average variance explained, and then you compare it with the pairwise correlations of those, constructs. You can comment on the discriminant validity as well. So this is one simple thing that we could do here. Another plugin that we have here is called model fitness measures. So we can quickly click here, and it will ask you whether you have some missing data. So I'll say no, my data has nothing missing here. So it will run the analysis, and once the analysis is run, it will take you to the output like that. So you can see what are the various indices that we have discussed, and what are the threshold values, and what is the interpretation. So few values which are not being met are being left here, but like CFI, SR, MR, RMSEA, these values are pretty excellent. So the threshold and acceptable and terrible limits are also mentioned here. And for that, they have given you the proper citations too. So if you wish to cite this tool, you can also cite this tool, using this particular thing. So these are the, wonderful utilities of the plugins that we can derive directly, running the things. So today what we have learned, drawing a model with the help of plugin, then commenting on the data of reliability and validity of the model, and we can also assess the model fitness kind of thing. So what we normally do in the modification indices here, what we achieve in the modification indices, that when you run the modification indices now, you will be getting the modification indices of the covariances as well as the standardized regression rates. So when you're working on the this model fitness, this confirmatory factor analysis, you normally look at the covariances modification indices. So if one particular covariance indices of the other term, like E1 to E3 or E4 to E5, is having a very high modification indices, then we add covariance term here, which I was telling you. So this way you will be able to, add a covariance term if they are referring to the one particular thing. So this is one thing that we do in that analysis, right? So that is what we achieve in this thing. One more thing that I'll share with you on the same page, if you will go here, you can download also this Excel stat tools. It is a wonderful file. So you just click here and it will be downloaded. It shows some kind of risk, but you can allow it because it is macro enabled file. You can actually allow that to happen. And what it does, I'll show you. This file is there with me. If you open this file, It is again a financial model developed by, oh sorry, it's a research analytics model, which is developed by James Gaskin and his team. He has a team of modelers and the analytical things. So they have developed a wonderful utility for various statistical things that can be done in the Excel itself. So for example, if you go to this validity master, so what they do, you have to allow this to happen. So if you have the correlation table here, you just paste it here. And if you have the standardized regression rates here, you just paste it here. And you can click on this link and this will provide you the output of the validity part. So that you can achieve in this. If you wish to have, some we'll be doing this moderation analysis tomorrow now. So this moderation analysis, if you wish to develop this kind of chart, so we'll just put on the values over here and this offers us this chart and even the interpretation with that chart on us. So these are various tools that he has developed using the Excel things. So if you want to check fitness indices, you can have your data set like this, and you can just reset this and rerun that particular data set, and it is a wonderful utility that he has shared. If you want to check the heterogeneity of the data, we'll discuss in the time series analysis. We can check it here. If you want to impute some missing data, you can do that. You just click the data set in this A1 cell and then run this impute missing data. That will be done. If you want to remove the data with the missing rows, you can just paste data here and then click here. The rows with the missing data will be removed. Scale assessment, if you wish to do, you want to do that, you can click paste the data here item wise, and this will give you the entire summary of that thing. So a lot many things. Even if you want to check the outlier variable, you can just paste the table here, and then you can run this outlier analysis. So a lot many things he has developed in this Excel model. You can use it like that. Nandini, for that thing, if you want to change the size of the diagram, what you can do, you can select that particular, variable first. Let me just select one variable here. So I'll just select one variable here. And if you want to increase the size, so you can just click on the change the type shape here, and you can change, the type here. So you just click here and then change. So this is how it can be, increased. The only thing is you should make sure that you are preserving the symmetries here. If you don't preserve the symmetry, then what will happen? Once you change this type, only that particular variable type will be changed. That is one thing that you should keep in mind. So then you have to do it all alone, one by one for everything. So that may not be, I'm trying to keep it uniform, but it may not be exactly uniform, even as smaller. So that is one thing. At the end, please share how the plugin in Drive, I tried, it's not happening. Okay. Open in Drive, and I'll show you that. That I can show you right now. The Amos has certain issues, so this I can show you what you're asking. So the plugins, let's say, I'll just show you the plugins. You just go to the plugins first. Okay, this is the plugins folder. You click here the plugins folder. The moment you click on the plugins folder, and we have another question coming from another participant. How can we justify using modification indices to improve model fit when we are not measuring those factors like the other terms? Okay, I'll answer that. So let us click here, and it is version 23 that I'm using. So I'm taking that version. So you will click here and you will download this folder here. So you have an option to download this entire thing. So you just click here, download. This will be scanned for viruses and then downloaded once you have that thing. So it has been downloaded in my folder now. So I'll just reach to that folder. So this is there. And once you must have WinRAR or zip to extract. So you just click here. It's a normally WinZip thing. So Windows WinZip option, will also work. So you can extract this in a folder. So this is extracted to a folder. And then what you will see, you have a folder with all the plugins here. So these are the plugins folder. This is the file folder. You have the plugins here. So you just copy these plugins, all the plugins, and then because I'm using 23 versions, so I'll go to the C folder, then go to the program files into 86 because I'm using that version, and then go to the IBM then click on SPSS, Amos, and then version that you're using, and then you will be going to the plugins here. And in plugins, you will just paste all the files that you have taken from that folder. So that will be pasted here. One more query, that was unanswered, and you can just do that because I have opened right now this folder somewhere. It's not opening it. Once you will paste it and then you close it, restart the Amos, it will work. So one question that has been asked in the last is like, how can you justify using modification indices to improve the model fit when we are not measuring those factors like the other terms? See, there are three ways of improving model fitness. The first thing is, if your factor loadings are very low, in general, like less than 0.6, 0.7. So if your, one particular variable is loading to the factor and having a factor loading of only 0.4, so this is not having a significant, loading. So one simple way out is you'd keep dropping such variables which are not loading to your factors. So that is one simple way of doing the thing. So you can simply remove those variables which are having poor standardized regression weights. Let's say less than 0.5, 0.6. So if all of the, the variables are having poor standardized regression weights, then we have an issue with the scale itself. So we cannot confirm or we cannot do that. So that is one point. So that is a point to remember, one thing. Second thing is, if you don't want to drop much of your variables, it's not a good idea keep dropping variables. Like you don't want to do that. So, and if like in this example, we have 3 variables each factor. So if we drop 2 variable from, one factor, we'll be left with 1 variable measuring 1 factor, not a good idea. So that's why we say in the beginning that, for each factor, you must ask initially like 5, 6 questions. So even if you drop 2 variable out of it, you'll be left with 4 variables measuring one particular construct. So that is one thing. Second thing is we can also try to look at the modification indices of the error terms. Error terms we are not measuring, but error terms have a very crucial role because, every explanation will have certain error and that has to be modeled. And Amos allows us to do that. So there's no harm in doing that. And that by default we are adding an error term to each observed variable. So if these error terms are somehow having a covariance, ideally the assumption says that they should have 0 covariance. Let me tell you. So if the covariance are having certain thing, and we don't want to drop a particular variable, so then it's a way out to put that covariance term between the other terms hailing from the same construct, which allows you to continue with the same amount of same numbers of variable because you don't want to drop variable for that reason. And if you have a lesser variable in one particular factor, dropping a variable may not be a feasible solution. So then in that case, we try and say that, okay, this is an exception where we are deviating and putting a covariance term to, 2 error terms. So you'll have to explain that part. Another thing is sometimes we see the standardized regression estimates are also there. We'll look at those values and then we see how they go. So that can be another way out of improving the variable thing. I hope that solves your query. Any other question we have? We can take that query for 1 or 2 queries more. We can take. What is the standard responses to draw a model? Standard responses to draw a model, normally drawing a model, like if we have nothing here and if I have a clean database here. So if I go with this kind of thing, so I'll just, let me just rotate these things. So this is the first set of thing. I want to draw the same kind of, variables for 5 times because I have 5 factors in my data. This is how you normally draw one particular variable. The sizes you can, increase later. So I'll do that later. So let me say if this is the thing and we have data sets in our variable. So this is the standard way of manually how we are doing that. This is how we are doing without, if we don't have anything in SPSS, that will work because we have not opened the SPSS. We have not done any moderation in the SPSS. We are just attaching a file which was in SPSS format. That's what we have done. We have not done anything in SPSS by now. This time I'm not using the component matrix also. So let's say I'm just dragging the numbers here. So I'm using simple traditional way. I'm using that thing here and just dragging B1, B2, B3 into the respective numbers. So this is the traditional way of doing it. So this seems to be working as of now. Let's see how far we can go if Amos allows us to work on that. And then working with the plugins, sometime, maybe a tricky thing too. So if your license, maybe some issues are there with the license thing. So then working with the plugin may be a tricky issue. So that's what we are doing right now. So we are manually dragging to each, measurement model like that. Now, if I use this plugin here, let me try and use one plugin, and I want to resize the observed variable. So I'll just click here. All the, variables which are observed in nature, they are resized. Still, this is looking clumsy here. So I'll click on the preserve symmetries here, and I'll just move the other term slightly away from the number. So it will be done. So this makes your diagram relatively looks better. So this is the normal traditional way of what you have asked for drawing a diagram. What we will do, we will select all the latent variables now. This is the traditional way we are doing, and let us select all the latent variables, unobserved variables. Select all the unobserved variables, and let me just increase their, number so that bit looks better. Let us also move them slightly on the righter side. So this looks better. And yeah, only truck can move the circle. And then I wish to, draw the covariances. So I'll just click on the another plugin here that is drawing the covariances. And this comes on this side. So once the covariances terms have come on this side, we can take the observed variables on the other side. There's no harm in doing that. So we can do that. So I'll click on the rotate thing here, and now I'll just rotate the observed variables on the right hand side because my covariances terms have come on the left hand side, which is okay. So it's a reverse mirror looking diagram that we see here. So this is the way we are doing the thing. Now another plugin we have which we can use. This is the entire traditional way of drawing the diagram, so we can use it. So what we can do now, we can name the unobserved variables. There are a few unobserved variables which we have not named. So let me just first quickly deselect everything. So, and I'll just quickly click here. I'll name it A. This is A. I'll be doing that naming for each, construct here. Keep clicking here and keep typing what you want to type. It can be any name of the construct. Keep doing that. The other terms, can be, I'll be telling you that I'm in a minute. So other terms can be renamed also. So now what you can do, you can name other unobserved variables. So name unobserved variables and this name all the unobserved variables like that. So let us reshape the other terms here. So that will look better. And if I wish to move them, so I can use the truck and move them slightly away from the thing. So it looks better now. So now the diagram is ready. This entire diagram we have done, traditionally that we would have done. So this is how you draw the diagram. I hope you got your answer of drawing the diagram manually. So that is fixed, right? Any other query which you want to take? You asked how to get estimates in the model. So for estimate, first you will save the entire diagram. You will select the analysis properties, what you want to achieve, and then you run the this calculate estimate. That is the process of calculating estimates. So I'll fix this issue with my lab assistant tomorrow, and then we'll be processing from this point onward in the tomorrow's session. I'm done for the day. If someone.
Thank you, sir. I hope all the participants there received the answers for the queries. So thank you, Dr. Ankit, for being with us once again and share your expertise knowledge. Now I invite Professor Yashwant Reddy to propose the vote of thanks.
Thank you, sir. Gratitude makes sense of a past, brings peace for today, and creates a vision for tomorrow. On behalf of the organizing committee, I would like to express our heartfelt gratitude to our esteemed resource person, Dr. Ankit Saxena, for sharing his valuable insights on constructing and testing structural models in Amos. Thank you, sir. Leader is one who leads us in right path. One such leader is our head of the department, Dr. Vijay Kumar R. Thank you, sir, for always leading us in the right path. Adding value to our institution is the unified support of all the wonderful teachers. We thank the entire teaching fraternity of the Department of Commerce for their active involvement. Thank you, teachers. I would like to thank all the participants for their active involvement. Your curiosity and eagerness to learn has made this event more thoughtful. Thank you all. Lastly, I would like to thank the FDP convener and the organizing team for the tireless efforts and dedication in making this event possible. Thanking you all once again, I remain.
Thank you, sir. As we conclude today's session, we invite you to join us once again tomorrow for another enlightening day of our FDP. Let's continue this journey of exploration and innovation in education together. Thank you and have a wonderful rest of the day.
Participate